All right, let's take a look at some more work with the first derivative test. Example number 11, this time we're given the function. We're not given the derivative directly, so we're going to have to do all of our steps in the first derivative test. We're told that g prime is equal to x cubed minus 12x minus 5, and we're being asked on what intervals is g decreasing. Okay, so let's go through our progression here. First thing we need to do, we need to get that derivative and set it equal to 0. Pause the video for a second, find the derivative of g, set it equal to 0. So yes, we're going to have g prime of x is 3x squared minus 12. Okay, and we'll set that equal to 0. And now we have to solve this equation to find our critical numbers. So if 3x squared minus 12 is equal to 0, yeah, we can factor out a 3. There's a couple ways we can go about this. So we can factor out a 3, or we can just say, hey, 3x squared is equal to 12. We add 12 to both sides, which means that x squared is equal to 4, and x is equal to plus or minus 2. Okay, that's one way to go about it. There's other ways to get positive and negative 2, whatever works for you algebraically. Okay, so now what do? We take our critical numbers and we're going to put them onto a number line. So we get our number line here down at the bottom of the screen. We've got negative 2 to the left, and we've got 2 to the right. We've got to pick some test values again. So you can take a moment, pick some test values. They don't have to be the same ones that I pick. It's entirely up to you as long as they're appropriate for the range. So we can go with, say, negative 3, 0, and 3. But by all means, you could have negative 5 and 1 and positive 5, and that would work as well. All right, so we're going to take our 3 test values, we're going to plug them into the first derivative, and we're going to focus on the sign. All right, so when we plug negative 3 into our first derivative, okay, so we have negative 3, we're going to square it, so that's 9. 9 times 3 is 27. 27 minus 12 is 15. That's a positive value. So negative 3 produces a positive value. And in fact, any number less than negative 2 will produce a positive value. Now we go with 0. We plug 0 into the first derivative. We have 0 minus 12. That's obviously negative 12. That's a negative value. So we can have a negative right there. And then 3 is going to do the exact same thing as negative 3. 3 squared times 3 minus 12 gives us 15 again. So we are positive. Okay? And we have our information now to solve the problem. Remember, the problem asks, when is g decreasing? Well, we have the mastery of our connections for the derivative. We know that a function is decreasing when the derivative of the function is negative. This plus minus chart tells us exactly when the derivative is negative, in between negative 2 and 2. Be careful here. Don't use your test values, because your test values might be different than my test values or your neighbor's test values. And those test values are literally just test values. The increasing and decreasing intervals, they work off of the critical numbers. So you want to make sure that you're using the brown critical numbers and not the blue test values. Okay? In between negative 2 and 2, the derivative is negative, and therefore our function is decreasing. Okay, so we have our conclusion, but we've got to write a statement which supports this conclusion. All right, so when is g decreasing? G is decreasing on the interval from negative 2 to 2. And again, we're going to stick with the open intervals. That just keeps everything nice and uniform. All right, why? Because g prime is negative.